I'm Dragan Savic, representing the Water Distribution Systems Analysis History Project. The purpose of this project is to document the history of water distribution systems analysis. An important part of this project is a series of interviews with engineers, modelers, researchers and practitioners who have made significant contribution to the field of water distribution systems analysis. Our interview today is with Professor Bogumil Ulanicki. Bogumil is a professor of engineering systems in the Department of Engineering and Technology at De Montfort University in the UK. He is also head of the Centre for Engineering Science and Advanced Systems and the Director of Research at Water Software Systems. He has a long history and research experience in control engineering with application to the design and management of complex engineered systems and water distribution systems in particular. This interview is being conducted on the 2nd of September 2015 in Leicester, UK, during the 13th Computing and the Control for the Water Industry Conference, one of the in the long series of these conferences. Bogumil, you're very active in water distribution systems analysis and CCWI conference series, being one of the main organizers of the latter. Your MSc and PhD degrees were in control engineering, which you obtained in your native Poland. Can you tell us how, with that educational background, you came to be involved in water systems and what involvement did you have in this area?
I think, Dragan, it was 1984. I was working at Białystok University and we had government project to control retention reservoirs in Poland. And I presented a paper in Zurich in conference, water conference, and I met Brian there and we had a chat. He was looking for somebody to work in his group on pub optimization, so invited me and I came to the UK in 1987. I remember the day, 23rd of February 1987. And then we started to work on different projects, mainly for water companies, but then European projects and EPSRC projects and so on.
Thank you, that's very interesting, and I would like to follow on with something that you mentioned. You worked very closely with Professor Kolbeck, and he's one of the pioneers of the water systems analysis and the application of the control engineering methods. Can you describe the role he played and what impact he had on your career?
When I came here, Brian was developing a package called GNAS. Really, it was developed. Brian pioneered water network analysis in the UK, and GNAS was developed and it was widely used in the UK by water companies, Thames Water, Yorkshire Water, Severn Trent. So initially it was mainly working on development of this package, training people in using of this package, but then we start to have projects in area of control of system. There was project for Yorkshire Water and then was project for Severn Trent, so I involved more in the control side, not only simulation. So, you know, Brian was a very good engineer, very understanding very well problems in water area and so on. So he introduced me to nuances of water distribution system. I didn't know anything about this before I came here, so it's like sort of my father in this area, I would say.
And again, related to that, can you tell us a little bit more about this CCWI series and what was the role Brian and you played in setting it up?
The first CCWI conference was in 1987. It was Leicester Polytechnic, then we changed name to De Montfort University. And it was first conference, probably major conference in water in the UK. We had a lot of people from industry and so on. And then we organized this conference more or less each 2 years, but then we joined force with growing rapidly group at Exeter, so, and then we Sheffield as well. We collaborate with Imperial as well with Czedo Maksymowicz and so on, and one of CCWI conferences was in Imperial College. So now we sort of each 2 years organize either in Exeter, Sheffield or Leicester now.
You have been very active in the development and application of control engineering methods related to pump scheduling and pressure management in water distribution systems. Can you describe and summarize the major research questions in those areas? What is the current state of the research is, and where your research in that area will focus in the future?
There are many aspects if you are talking about optimization or operational control or pump scheduling or whatever, which are linked to optimization. First of all, you have to create a simplify model. Model reduction is very important thing. So I very much appreciate my sort of work in this area with Fernando Martinez from Valencia University. He came here in '95, and we developed this model simplification method, which is very efficient and produce very simple model which is hydraulically equivalent to original one. Then there are different aspects, even simple things like model of pump station, so it is robust, it doesn't have singularities and so on. So I was working on this and publishing in this area, and Lou was planning to use my model of pump station in next version of IPANET, so it was quite exciting. On pressure control, I was initially working on steady state side, so it's like producing schedule for pressure reducing valve and so on. But then I come across in industry different problems which are dynamic, like stability of pressure reducing valve and, for example, cavitation in pressure reducing valve. So this interests me a lot as well. So there's a lot of things related to this.
You have been also instrumental in developing modeling and control software for WDSA. You touched upon a little bit with that first work, with initial work with Brian Colbeck. Can you tell us more about the history of that development? What is the state of that development now, and any future plans?
Yes, we had developed optimization package which we call Finesse, which was many part. One part was this model reduction method, then pump scheduling. There was part on pressure control as well. So we hope to commercialize and sort of sell it at commercial project, but part of this software is very robust, working 100% like model reduction or pressure control, but some of these components like scheduling is not working 100%. It works in 95%, and water industry doesn't accept anything which is 95%. They only accept solutions which are 100%. So, but you know, so at the moment we stop development of the software. We have these pieces which are very good and so on. Maybe we can contribute to IPANET project by providing some model reduction module or something. But then I got more in industrial short projects. I like it because, you know, if somebody comes to me and saying, you know, we have this problem, nobody can solve it, can you help us? So it very excites me very much that I am the person to solve it, not anybody else.
That's very good, because that involvement with the industry is quite interesting, because your work is both theoretical and practical, and you required really to deal with practical problems. Can you tell us about your involvement with the industry, UK water industry in particular, and their involvement and impact on the direction of your research? Yes,
so going back in history, I started here, we had a pump scheduling model for Yorkshire, project for Yorkshire Water. Then it was a huge project for Thames Water. It was development on ring main in London. It was the biggest civil engineering project in the UK, maybe in Europe. And there was like ring main going around the London, water flowing in two directions and meeting around some Buckingham Palace. So we use GNAS and some developed software, bespoke software to design this system. I sort of arrived at some sort of concept like time distribution function, least cost surface, balance sets, which we sort of use to have a global picture of the huge system and design pumping station. So pump station around shafts are designed by our group, so it was very rewarding. So it was Thames Water, and then we had a project in pressure control for Thames Water. Then we have a project for affinity water, now they call affinity water. And recently I got involvement with Scottish Water because they have this project with instability of pressure reducing valves. They didn't know what's happening. They thinking there is probably of transient or something. Then I discovered that pressure reducing valve from control point of view has very nonlinear characteristic, and gain is changing for small opening is 10 times bigger than for big opening, and this causes instability from control point of view, so we fix it. And then I suggested they may have problem with cavitation as well. We start to work in this area, so we had 4 projects with them, the most recent our projects.
You have mentored numerous postgraduate students as an academic supervisor at De Montfort. Can you tell us a little bit more, how do you come up with a topic for those students? Do they come to you with a general idea what they want to do, and then you narrow down that to a specific topic, or do you more often come up with a specific projects for them from the day one?
My approach is to link PhD to ongoing projects. So I have particular project, whether it's EU project or industrial project. I try to students to be involved in this way. So problems are practical. We are doing very practical research. So rather than invented problems, we are solving real problems. And I think this gives a student direction, focus, and motivation that results will be seen in practice.
Good. Finally, I'd like you to do some crystal ball gazing. Where do you see the profession heading, or what areas should the profession undertake in the next 10, 15, 20 years?
I think that any conference or project application start with a statement that we have not enough water, is water shortage, and so on. In fact, on our planet, amount of water is the same. It doesn't change. So water is simply in the wrong place and wrong time, but volume of water is the same. So I think the challenge is how to use this resource in a right way. So we have to think about water recycling. We have to think how to, for example, treat wastewater to get drinking water and so on, how to replenish groundwater. So, and this sort of thing excites me, and I think that we have to think about sort of be aware that we cannot consume more and more, that we probably have to sort of reduce our consumption somehow in any aspect, including water. And this is the direction I would see that we developing, that how to recycle water, how to save water, and so on, and how to use it efficiently.
Thank you, Bogumil.
Thank you.